This talk is probably going to take up the entire time allotted, which is why I regret to inform you that I'm changing the title of this talk as immediately. So this talk is called Almost Everything You Ever Want to Know About Web Authentication in Python. I realized recently that this is way too much content to squeeze in here, so I'm going to do my best. If you guys have questions, save them till the end. If we have time, I'll get to them. Hopefully I get the 80-20 rule, teach you all the cool, fun stuff, and leave out all the boring, uninteresting things for later. So, one final thing to note. If you want to tweet at me, this is my Twitter handle. So you can send me hate or love, doesn't matter, whatever you guys want. So my name is Randall Degges. Thank you so much for coming to check this talk out. I really appreciate it. I run developer advocacy at this company called Okta. That's where I work. We're an API service. We store people's user accounts and personal information, and we try to make it easy to build sites with registration and login and single sign-on and all that fun stuff. I also do a ton of Python, Node, and Go work. I've been writing Python since about 2004, so I've been doing it for a while now. I do a lot of open source projects, and for the last several years, I've been working primarily on security and cryptography tools there. So that's my experience. So, what I'm going to be showing you guys today is the journey that happens when a user goes to a website, gets to a login page, types in their information, and hits go. A lot of stuff happens behind the scenes, and for people like me, I love to geek out on this stuff and really understand what's going on behind the covers there. So I'm going to walk you through every single step along the way to fully understand what the hell is going on. So that's the plan. And my sort of optimum scenario here is that by the end of this talk, you understand it really intimately, and you'll be comfortable talking about it, blogging about it, whatever you guys are into. So, in order to do this, we're going to build a real simple site. It's going to have a few main pages, a registration page, a login page, and a dashboard page that someone has to log into to access. So that's the goal. So we're not wasting any time. Let's get right into it. I'm only going to make 2 assumptions about you. Well, maybe 3. The first one is you're at least a little bit familiar with web development, okay? I'm hoping that's a given. The second one is that you're at least a little bit familiar with Python. Now raise your hand if you're a new Python developer or sort of consider yourself beginner. Okay, most of you guys are hardcore elite Python programmers. That's fantastic. It's going to start slow. We're going to get to the really hardcore stuff towards the end. So don't get bored. And lastly, I'm going to assume that you're willing to install MongoDB, or at least pretend that you will for the duration of this talk. Now, I probably lost 90% of you right now. And I just want to say, I don't like MongoDB. I'm not recommending it. Okay, I'm a Postgres guy. I'm just going to show you the MongoDB examples in here because it takes way less code to showcase, okay? So this is not my endorsement for MongoDB. So again, don't judge me. I don't want to see tweets about this. Also, because Django is so popular in the Python community, it would really suck for me to give this talk showing how this works in Django. The reason why is because it'd be like a one-line talk and it'd be over before it even began. And so to keep it interesting, we're going to use Flask. And you don't need to know Flask. I'm going to walk you through it, but just keep that in mind. That's why I'm picking this specific technology to showcase. So to get started building the app, we're going to have this real simple directory structure, okay? We're going to have one file, server.py, where all of our Flask code is going to live. That's going to be our web server. We're also going to have some HTML templates because it's impossible to build an authentication site without a front end. And keep in mind, I'm not a front end designer, okay? So because I'm not a front end designer, I really like to get the hard stuff out of the way first, which is the design work. So I'm just going to breeze through this, all right? Now, when you're building templates, how many of you are familiar with the Jinja templating language or some subset thereof? Pretty much everyone. So I'm not going to spend a lot of time here. But the idea of it, for those of you that aren't familiar, is that templates in Python are just HTML code with a little bit of fancy stuff added. That's the breakdown. So for instance, this guy right here is a variable. You can insert a variable called title into this HTML template, makes things a little bit nicer. You don't have to repeat the same boilerplate stuff over and over again. You can also insert blocks of other HTML code into your Python templates here, which is what you're seeing in this block body directive. And we'll get to that in a moment. So this base template is going to allow us to reduce boilerplate everywhere else. So next up, we're going to quickly define a home page. And just to explain the templates a little more, the first thing we do at the top of the file here is we extend that base template you just saw a second ago, which says no boilerplate needed. We're going to use the set command to set that title variable from earlier to show that this is the home page of our site. Then we're going to insert some basic HTML into the body section of that previous template you just saw. So when this thing renders and runs on the home page of our site, you're going to see a real pretty, simple little basic website. Now I'd like to show you the registration page we're going to be using. There's a simple HTML form in here. It's a post form, and it has 4 input fields: a first name, a last name, an email, and a password. Don't forget that. And then finally, we have a login page. And just like the registration page, there's a couple input boxes. In this case, we're only going to accept an email and a password. Sounds pretty standard, right? Nod your heads if you agree. Cool. And then finally, we have this dashboard page, and it's doing nothing fancy. All it's going to say is, welcome to the dashboard. You are now logged in. So this is what we're building. So now that we've got the hard stuff out of the way, like I said, let's do the more fun and interesting stuff. So we're going to first start by building the most basic possible Flask web app to show those pages and nothing else. Really, really straightforward. So up at the top of the file, we're going to import Flask and the render function, which we're going to be using to just show this HTML template. The next line of code down, where we define that app variable, is standard Flask stuff. It's where we create the actual web app instance that Flask is going to use to sort of do all the magic that it does behind the scenes. And then the rest of the file here, these are called views. This is just functions that run when a user hits a particular URL. Pretty simple, right? Now to elaborate on that a little bit. So if you haven't been exposed to this before, I'll just cover it real fast. But basically, this decorator, the app.route decorator, all it really says is that if the user hits that URL in parentheses or in quotes there, the slash URL, then we're going to run the function below. We're going to return some response that goes to the user. So in this case, we're just going to show that HTML file from before. Pretty simple. Now, if we were to go back to the command line, having inputted all this stuff, and actually run the Flask server, just real simple, you say flask_app equals server.py, for instance, Flask run, starts up a local development server. It's going to run on port 5000. You go check it out, and this is what you get. So again, I'm not a designer, so I don't want to see tweets hating on the design either. Now, a pet peeve that I have, because I do a lot of security work and stuff like that, is when people talk about authentication and security, they never fucking cover the most fundamental basic thing, which is the front end, okay? And like, when you're talking about logging people in through a website, you need to start talking about the data collection part, which happens through HTML forms. It's really important. People always leave it out, and I can't stand that, so I'm getting too angry. But basically, everyone knows what HTML forms are. They look like this. This is our registration form, okay? The fully rendered version. And now again, no surprises here. It's a post form. It's got some basic input boxes there. Looks pretty cool. There's a dancing stick figure guy. But when the user goes to that page and inputs their data and sends it to our web server, we need a way to capture it and actually work with that data. So that's the first thing we're going to do. Like I said, I'm not leaving any parts out. We're going to go through each step to fully understanding this. So we're going to import some new stuff at the top, which is pretty cool. We're going to expand our route declaration in that decorator up there. We're going to include this methods argument. And we're going to basically tell Flask that, hey, if a user sends either a GET request or a POST request to the /register URL on our site, then we want to run the function down below. By default, if you don't specify that, Flask will only serve or will only run that function for GET requests. And that's not what we want, because when the user sends us a POST request, it means they've clicked submit on the form, and they're sending data to us to register an account. And then next, we're going to do some basic checking there. So we're going to say if the method of the request is a POST request, then we're going to show the data the user sent to us, which is this request.form variable. So that data is like this dictionary-like object that contains all the data from the form. Then we're going to use this built-in function called JSONify that Flask provides to just transform it into a nice little JSON object and show it to the user. So if you were to go test the site out like right now, what you would see is the following. You go to the form page, you enter your registration information, you click submit, and bam, you get this response back with all of your information echoed to you. Everyone following? Cool. So now that we figured out how to receive the information, right, we have to fucking do something with it. Right now it's useless. So we're going to store it in a database. And again, this is where we're using Mongo. I apologize. If you're using Mongo and you want the world's fastest explanation about how it works, then you're in luck, because that's what I'm going to do. if you've never used Mongo before, the first thing you need to do is either create a database or get a database that exists. In Mongo, this is all one command, the use command. So if you say use test, for instance, you're going to create this database called test and immediately switch into it. Next up, Mongo doesn't have tables, they have collections. They're the same thing, they are basically just a place to store information. So user information, for instance, book information, whatever sort of data type you have, you'd have a collection for it. And the show collections command basically shows you all the existing tables. Then finally, if you want to either create a collection or insert some stuff into it, Mongo calls those documents, by the way, not rows, you basically say db.users.insert, that could be db.books.insert, it could be any collection name you want, and you give it a JSON document like this. And what happens is that will actually either create the table or get it if it doesn't exist, and then insert that information into the collection. Everyone following? Cool. And then finally, there's this nifty find command you can use, which just lists everything in there. It's basically like doing a select star from users. Making sense? Cool. Now, in order to work with this, in our little Flask demo app here that I'm walking you guys through, we're going to use the /pymongo library that Flask has. And this really makes it simple. It simplifies a lot of stuff. You initialize it like this. You give it this config object, which is just the name of your database. And once you initialize the library by saying mongo equals, /pymongo app, that's going to connect to the MongoDB database on localhost, use the correct database name that you specified above, and sort of handle all that stuff for you. So that's the only setup required. So now, we go back to the core thing we're building, right? Enough detraction. So we have this registration page. Users can submit data to us, and right now we just show it back to them as a JSON data. But now we want to store some data in there. So we're going to go back to the registration code. We're going to modify it to add this one line right here. Now we're going to say mongo.db.users, the collection name, .insert1. So that's telling Mongo we want to create a single document in this collection. And then we're going to do the same thing we did before. We're going to take the form data that was given to us, which is that. We're going to convert it to a dictionary object because Flask uses this like special object by default. And that is going to store it in the database. Then once that's done, we're going to use this redirect method, or this redirect function, excuse me. And we're going to redirect the user to the dashboard page. Everyone following? So we're going to, the user sends us their info, we store them in the database, and then send them to the dashboard page. Cool, well this shit's almost completely built out then. That's fantastic. Now, if you were to run this and test it out immediately, and then go into Mongo and actually run the find command, you would see that in fact, you have built the most secure website in the whole world. So all of my information is stored in the database, we're ready to ship. This is like some production Yahoo level stuff right here. Now, let's talk about authenticating users, right? So we're able to store users, but now we need to actually log these guys in. So we're going to go to the login view. We're going to set up the same methods for get and post as we did for our registration code. And we're going to use the Mongo find1 command to find the user by their email address. So when the user goes to the login page, types in their email and their password, and hits log me in, we're going to receive the user's email in that request.form sub email syntax there. We're going to grab their email address, and we're going to search Mongo for that user's account by their email address. Then we're going to compare the password from Mongo that was saved earlier to the plain text password that we received in the form. So if the user entered the correct password, we're going to again redirect them to the dashboard and log them in. Making sense, right? Cool. But now we get to talk about something that I actually find interesting, which is sessions, okay? Sessions are like amazing. They get a lot of hate nowadays, and we'll talk about that later if we have time. But sessions are absolutely fantastic. So let's see how they work. Now the idea behind sessions is actually sort of fun because back in the day, right, when sessions didn't exist, the web was just the shittiest place in the entire planet. And that was because if you went to a website and you logged in to view something, you had to type in your username and password using this HTTP basic auth thing. So you go and you log into a page. Then if you want to view another page in your website that required login, and you clicked a link to go to like the billing page or something, for instance, you have to re-enter your username and password again because you're on a new page and you have to re-enter it. And the reason why is because the HTTP protocol, which makes the entire web work, is stateless. It doesn't give a shit about anything. It doesn't care about you. It doesn't care about your information. It doesn't remember anything. And so it's pretty useless on its own. Sessions are like the loving family that like helps you get through this nasty mess that is the internet. And the idea here is that when a user logs into your website is gonna send a message to the browser that says, hey, I want you to remember who this user is by some unique identifier, okay? Like some unique ID for a user. And from now on, every time you send me a new request to my website, I want you to send that unique ID back to me so I can remember who this person is. That's the idea of a session. Does that make sense to everyone? Cool. That's what it is. All right, now let's talk about cookies. So a lot of people think cookies are files. That's actually a misconception. We're gonna get into that. But the way cookies work is they are the mechanism for remembering sessions, okay? So when a user logs in or something happens and the web server tells the browser to remember something, it does that using cookies. So the browser will store cookies and send it back to the website on every subsequent request. Now, before we dive into another level of depth here, let's talk about how HTTP actually works quickly. So whether you're requesting data from a website or whether you're sending data to a user, like in a response, every HTTP request has two parts. There's metadata about the request called the HTTP headers. This is just key value data. The most popular header I can think of is the user agent header, which I'm sure you've all heard of. So every time you visit a website, for instance, your browser creates this user agent header, which says, you're using Chrome version 1.2.3, and sends it to the web server so that it knows what browser you're using. So headers just contain metadata about your request. Now, all the fun stuff that happens in HTTP is actually in the body, okay? So that's the part you should actually care about. That's where the HTML code is, the JavaScript, the CSS, the JSON, whatever else you're interested in is almost 100% of the time in the body of the request, all right? Now, that brings us to cookies. So let's talk a little bit more about them. So cookies are really just HTTP headers. They're just metadata about a request. That's literally all they are. They're a single string, they're super basic, nothing fancy. And when you want to set a cookie, so if you're a web server and someone sends you a request, and you want to tell a browser to remember something, you use this header. So you return a header called set-cookie, and inside of it, you say like variable equals value. That's all it is. It's like a variable assignment in a string. Now, if you want to set multiple cookies, this is the syntax to do so. Super simple, super basic. You just throw a semicolon on the end and repeat as many times as necessary, up to 4 kilobytes in length. Now, reading cookies, so once a browser has remembered some stuff for you, it is going to send it back every time you make a new request to the site, right? The way it does that is it also sends a header. And the only difference is that this header is called the cookie header instead of the set-cookie header. Pretty simple, right? Making sense? Awesome. Now that we know the mechanism by which sessions work, let's talk about how we actually implement this. In Flask, it's super simple. They have this session object that allows you to sort of easily create these cookies, retrieve them, do all this hard work. So that's what we're going to use. So if you import that, the next thing you need to do is configure this secret key variable for Flask. And what this is it's a long random string that you're going to create. You're never going to share it anywhere. It's just going to run on all of your web servers. It's going to be the same on every single web server. And what this does is it's used during cryptographic signing process when cookies are being set to basically make sure that like you can't go into your browser and change your identity to someone else. And we'll talk about that more at the end if we have time. I have some extra slides in there. But that's the gist of it. It's helpful for session security. Now, if we go back to our login page and we want to actually make it remember who someone is, we're going to use the session stuff down here. So once users logged in and we've retrieved them out of the database and we've made sure their password is verified, we're going to say like session sub ID equals the user's ID. Now, if you guys noticed earlier when I created that user in MongoDB, the user got this underscore ID field created by default. It was a long random number. Now, that is actually an object that Mongo creates. It's called an object ID object. So we're going to convert it to a string first. So it's basic data type. And we're going to store it in this session cookie. That way, later on, that will be the unique ID that we use to remember who this person is. That making sense? Fantastic. Now, if you test this out and you go to log in, you go into the Chrome developer tools and you actually want to see what this looks like under the covers, this is what you see when you log in. You see a new cookie has been created called session, and the value of that cookie is this really long random looking string. And this is the cryptographically signed cookie value that we saw earlier, okay? So again, we'll talk about cryptographic signing later, but just know that it's a secured way to store this sensitive information. So now, we've got this, right? But the biggest problem I see, everything else is perfect, is that our dashboard doesn't care if you're logged in or not. And so we want to fix that. Now, we want the dashboard to remember who you are so you don't need to re-enter your credentials. So we're going to use the session stuff we just implemented to take care of that stuff. So we're going to say if the ID value is not available in the session, so if there's no cookie set or the ID value doesn't exist, we're going to redirect the user to the login page. That way we force them to log in. Otherwise, we're going to talk to MongoDB and we're going to load the user out of the database by their ID, not by their email. So because we have that ID available, now what we can do is we can search by the ID. It's a fast operation, it's an indexed field, and get the user object back to us. And then finally, if the user exists in Mongo and everything's cool, we'll show them the dashboard page. So we just implemented secure login for the dashboard. Looking good so far, right? Great. Oh, and if everything's okay, yeah, there you go. Now, let's talk about storing passwords, because a lot of you are sitting here, you're all experts, and you're just like, fuck, this guy sucks, he's the worst. So I want to show you that I'm not actually the worst. So right now, in the database, all of your passwords are stored in plain text. So see how you can see my password there? It's Woot. That's actually what I use for my bank account, so don't go log in. That's why, as programmers, we do password hashing to sort of secure these passwords so that developers like us can't read them, we can't accidentally leak them to the world, and things of that nature. So I'm just going to quickly talk some shit about password hashing. Oh, sorry. That's the next slide, actually. We're going to quickly talk about what password hashing is first. So password hashing is when you take a password and you convert it into this really long random looking string. That is the idea of password hashing, okay? It's not very complicated. If you read blogs on the internet, it might tell you otherwise. Now, there's two rules you need to know about password hashing to be like in the top 1% of developers like everywhere. The first thing you need to know is that the same password, when you hash it, always gives you the same hash. Okay, so this long random string, it's not actually random. If you hash the password Woot, and you get a hash, and then you hash it again, you get the same long random looking string each time. The second thing you need to know is that once you have this password hash, there's no way to like decrypt it back into the original password. It's called a one-way function. So once you get a hash of something, you can never turn it back into the plain text password. That's why hashing is considered the best way to store this information, because it's a way that you can validate that something is what like truthful without knowing what it is. Sound good? Cool. Now, hashing algorithms, you read about them online pretty much everywhere. There's really old ones like MD5 and SHA-256. There's new, more modern ones like bcrypt, scrypt, argon2. And then there's a bunch of other things that fall all across the spectrum. I've sort of ordered these from like oldest to newest in terms of like greatness as well. But basically what you should know is if you're using anything that's not on this list, then you probably want to upgrade your stuff. You can ask me questions about this later, like why does Django, for instance, use PBKDF2 or whatever. We can talk about that after. But yeah, so the things you want to use on this list are bcrypt, which is awesome. It's been around since 1999. This awesome guy named Bruce Schneier is the author of it. It's been well vetted and tested. There's scrypt, which was created in 2006 by Colin Percival. He's the head of the FreeBSD security team and a bunch of other awesome security projects. It is significantly stronger than bcrypt. And then finally, there's argon2, which has been around for close to 3 years now. It's becoming a new NIST standard. So in the next handful of years, this will become a de facto standard for a lot of us. Now, my recommendation currently is to use bcrypt. The only reason I recommend that, even though both scrypt and argon2 are sufficiently more secure than it, is because it's been well tested and it's like the default safe recommendation at the moment. So just know that. Oh, and if you want to talk more about this afterwards and learn all sorts of fun, interesting things about crypto, come sit with me at lunch and we'll talk about it. Now, let's talk about how bcrypt works, since that's the recommendation. The way it works is, let's say you have a password. It's a string. It's really basic. You're going to run it through a bcrypt function that's going to give you a hash. And if you print that hash, you will see that it is, in fact, just a really simple string. Okay? Pretty basic. And that's a real hash, by the way. That's what it looks like. Now, if we want to go back and improve our registration codes so that we're not storing people's sensitive information like some big companies you're aware of, then what we're going to do is install two libraries, the bcrypt library and the passlib library. These are going to make this really, really simple for us. Now, in our registration code, we only really need to do one thing. We're going to take the data that the user sent to us to register their account, convert it to a dictionary. Then we're going to hash the password data inside of there and override the old plaintext password. Then we're going to store that new user object with the hashed password inside of Mongo. And that's pretty much it. So one line of code lets us do this. It's not a lot of work, as you can see. But now the problem is that our login code is broken because previously we were doing everything in plain text, right? The user's password was stored in the database, just plain. And now if we go to compare those two things together, they will be incorrect if you try to log in. So we need to upgrade our login stuff as well. And all we need to do there is instead of comparing the passwords manually, like the password the user sends you and the password in the database, you use this bcrypt.verify function and it will handle that for you. So the first parameter is the plaintext password the user is sending to you to log in. The second parameter is the hashed password that's stored in the database. And assuming everything's cool, you will log the user in and send them to the dashboard. Everyone following so far? See some head nods? Cool. If I lost you, come see me after, okay? Seriously. Now, if we go back into Mongo and verify this, you will see that in fact, we are storing passwords in a much more secure way now, so hey, we're not as noob. Now, are any of you looking for a job? Raise your hand. Anyone? Okay, a few people, cool. So super easy way to get a job, I swear. Go check out this website, plaintextdefenders.com. It's a website that this guy curates where he finds companies that are storing your passwords in plain text and publicly shames them. I'm officially endorsing it. But basically, easy way to get a job, email these guys and say, hey, I was checking out your website. I noticed you're storing all user passwords in plain text. I just saw this awesome security talk. I'd love to come fix this for you. Please hire me. It works like 99% of the time. And if you're not looking for a job, then you can go here and publicly shame them anyways. It's also really, really fun. So it's a win-win. Okay, so side note, refactoring, all right? So I'm like obsessed with refactoring code. I just can't really help it. I waste like, well, this is recorded, my company won't see this, probably. But I waste like 20% of my time refactoring stuff just for fun. So let's talk about refactoring smart user loading. And this is not critical, but like, it's pretty critical. So the idea here is that once a user's logged in, as you saw earlier with our dashboard code, we had to like do all this crap that we hate doing, like look at a session variable, check to see if it's there, talk to the database, whatever. That stuff's boring, everyone hates it. That's why people like Django so much. So we're going to make that a little bit easier. What we're gonna do is create a user variable. So if you're inside of any of these view functions, once the user's been logged in, you can just reference the user by this user variable. You can say user.firstname, user.lastname, user.email, whatever you want. It's gonna make our lives much easier. So the way we do that is like this. We define this load user function and we tell Flask to run it before every single user request. That's what that fancy decorator does. It says run this before other code is run. And inside of here, we're gonna do the typical login stuff that we saw earlier. We're going to check for a session ID, load the user out of the database, and we're going to delete the user's password hash out of the user object, okay? Now the reason I'm doing this is because let's say you are running this website in production and you have the password hash available to you. If you accidentally print the user object to the console or something, the user's password hash is there, and that's bad. If you accidentally send it to the user in a template, that would be pretty bad. Now, in the real world, like I said, don't use MongoDB. But if you do, the best way to do is to write a special query so you never actually retrieve the password hash from the database in the first place. That's an exercise to the reader. Too long to fit in this one slide. And finally, once we've created this user object, we need to then do this special proxy thing, which basically tells Flask that, hey, when we're running inside of a request and a user's been logged in, make sure that the user object that we're referring to is the current user object. So now, and I'll show you how this works in a second, by the way. So now, let's talk about forcing authentication. So in most sites, you want to have a lot of pages where users need to log in to access them. probably more than just a single dashboard page. And so what I like to do is create a decorator called login required. It looks exactly like this. And what it basically says is like, hey, if there's no user, then get the hell out of here and redirect them to the login page. That's pretty much it. It's an easy way. And I mentioned the reason this works is because in the previous slide, that user object that we provided allows us to do this simple checking, like is a person logged in, yes or no. And finally, if they do have a user object, which means they're legit, then we say, hey, welcome to the site, you can view any page you want. And finally, it all comes together, it looks like this. We throw our login required decorator on our code, and then we can also reference the user object inside of it, and that's pretty cool. It doesn't suck so bad anymore. So now, real quick, let's talk about security best practices, really fast. So first off, you should always be using SSL. I know pretty much everyone says this in the world, but I feel compelled to do it one more time. If you're not using SSL on your site, like HTTPS, then anything that a user submits to your site to log in, for instance, their email, their password, that can be read by anyone on the network. So if you're logging in from Starbucks Wi-Fi, everyone else on the Wi-Fi can see it, it's a bad idea. So SSL is required no matter what type of authentication you're using in any scenario, absolutely required. The next thing is cookies are a fantastic, mechanism for logging people in, but there's a few things you need to know about cookies and use in order to make them more secure. These are absolutely mandatory, okay? And the way you control them is through these settings in Flask. So the first one, session cookie HTTP only, you always want to turn this on. What it does is it tells the browser that, hey, when you store this cookie, never let JavaScript access the cookie. The reason why is because a lot of people, the world is dangerous and stuff. JavaScript is without question the most dangerous thing in the world right now. So you definitely don't want JavaScript to touch this. The second thing is you have session cookie secure. And what this does is it tells Flask like, hey, if we're going to set a cookie, we can only do it over a secure connection, over HTTPS. So it's just an extra measure to make sure you don't fuck something up. All right. And then finally, permanent session lifetime. This lets you tell Flask like, how long should this cookie last in the browser? Do you want the user to stay logged in for 10 minutes, an hour, a day, a week, a month, whatever? But you should set this value to something that's reasonable for your application. And then finally, I'm sort of showing this talk because it's really fun, but also just because it's great to know this, but if you're building a real site and not just something for fun or security research, you always want to use a popular open source library to do this stuff for you. And that's where things like Flask Login, Flask Security come into play. If you're using Django, you're pretty good by default, although we can talk about it afterwards if you want. My company also provides open source libraries to do this stuff, which you're more than welcome to use. And the talk isn't over, by the way, but this code and these slides will be online afterwards. So I'll upload those later today. You can tweet me or my company. We publish all sorts of interesting security research and just fun developer stuff. Now, how many of you came here today to hear about JSON Web Tokens? Raise your hand. Oh, almost no one. Wow, I'm sort of shocked. Well, a lot of people ask me when I give this talk, like, hey, why aren't you talking about JSON Web Tokens? That's like all the hotness in the world. And that's because they are horrible, and you should never use them. Pretty much everything you ever hear about JSON Web Tokens online says they're fantastic, and I'm here to tell you, everyone is completely wrong. So I actually have like a 2-hour talk I would love to give on every single bullet point why. I'm gonna cover some of the most important ones in my opinion right now. And again, we won't have time for questions, so afterwards come and talk to me about it, because like it's really, really important. So if you're wondering what JSON Web Tokens are, I'm gonna quickly summarize it for you. It's JSON data that is cryptographically signed. It's not fancy and it's usually not encrypted, okay? And that leads a lot of people to the question, well, what the hell is a cryptographic signature and why do you keep saying it so much? Well, if I write a letter to you, I'll usually sign my name. And you know by looking at that letter what my name is and what my signature looks like, and so you say, hey, I trust that this letter was written by Randall. That's what a cryptographic signature is. It's just a way to identify something as being written by someone. So what do JSON Web Tokens actually do then? Well, they prove that some data was generated by someone else. Now, how do people use these? I'm gonna get a lot of hate right now for 1 second, but let me explain the case I see most often. When a user logs into a site and verifies their password, instead of storing a session ID for a user, like in the session, they'll store a JSON Web Token for the user. JSON Web Tokens not only contain like the user ID and email and stuff like that, but a lot of other information. They have a lot of these required claims, like other pieces of data that you can throw in there. And some of you were probably thinking, as I was explaining that, well, that's not fair. if you're using JSON Web Tokens, you should store them in this other thing called local storage, not in a cookie. And you guys are all wrong, okay? You're wrong, so I don't want to talk about it more. But I will. Sorry. So the reason you're wrong, oh, I went too far. The reason you're wrong is because I'm telling you you're wrong, first of all, but also OWASP, the largest internet security think tank, also says you're wrong, and for some reason, no one cares about this. It drives me crazy. But yeah, don't ever use it for sensitive information, including login stuff. If you are, huge problem. Now, why do they suck? There's a million reasons. Again, I have a 2-hour talk on this, but the gist of it is, first of all, they're inefficient. So they're much larger than an equivalent session because they packed more information into there. Okay? Now, one of the benefits they have is you can shove more info in there, but as you will learn afterwards, this is actually totally useless in our case. The next thing is, for 99% of web apps out there, you're going to be talking to your database. Now, a lot of people think the benefit of JSON Web Tokens is they help you scale your app by being stateless and storing all this user information, so you don't need to talk to the database to grab the user details all the time. And again, these people are crazy wrong, because in 99% of apps, you're going to be talking to the database no matter what, especially if you're building a secure site and you need to do things like revoke tokens when they're not valid, expire someone's stuff. We can talk about that after. And finally, some people, I've heard this argument a lot, they say, well, JSON Web Tokens are more secure than session cookies. And they say, I asked them why, and one guy told me, well, they're signed twice. The token itself is cryptographically signed. The cookie is also cryptographically signed. And so therefore, it's more secure. And again, if you sign a letter twice, it doesn't really do any good. It's just a waste of resources. It proves absolutely nothing. So that's a waste. So what are they good for? I'll give you one use case: resetting a password. So if a user talks to a website and says, hey, I want to reset my password, the website says, okay, and sends you an email with a JSON Web Token in a URL that you can click. And what's great about this is JSON Web Tokens are stateless. You can embed something. And remember, they let you prove that something was generated by someone else and is trusted. So then if the user clicks that link, the website can validate the JSON Web Token and say, hey, this looks valid because it's cryptographically signed. I trust that this user has permission to reset their password. And then actually reset the user's password. And this is absolutely fantastic because there's no database hits there. It's a trusted thing. And the most important part is the token is only being used a single time. JSON Web Tokens were meant in the spec for proving something is valid a single time, and that's it. So persisting state in them is absolutely horrible. So in summary, JSON Web Tokens should never be used for a persisting state, especially login information. It's a horrible idea. Use cookies because they're more efficient and less bad for you. And if you do want to use tokens, then please don't use them unless you absolutely are sure that you're doing the right thing. Again, thank you guys very much. This was fun for me. I hope you enjoyed it a little bit as well. And come hit me up after to talk about fun, geeky stuff. Yeah, I think we're out of time too, so we're done, right? All right, cool. Peace.